I'm Anil Kumar sharing with you 4 excellent questions on rational functions. It is exam review part 2. I'll also provide you with the link of part 1. You should watch that also. Question number 1 here is, write an equation to represent function with following conditions. Reciprocal of quadratic function, asymptotes with x equals to minus 5, x equals to 4 over 3 and y equals to 0. For x less than minus 5 or x greater than 4 over 3, y is less than 0. That's question number 1. Question number 2 is, determine equation of tangent line to the graph of f of x equals to 3x plus 6 divided by x at 2, 6. Question number 3 is, solve x squared plus 1 over x squared plus 2x plus 2 over x equals to 13. Now these last 2 questions are bonus questions, right? So I hope you get them. Question 4. Find a, b and c such that a over x plus 1 plus b over x minus 2 plus c over x minus 2 whole square equals to x minus 1 over x plus 1 plus x minus 2 whole square. Copy these questions, solve them, and then look into my solutions. Let's take them one by one. Write an equation to represent function with following conditions. We are looking for reciprocal of quadratic function. And what we are given here is asymptotes. So we are given vertical asymptotes. Whenever we write x equals to something, these are vertical asymptotes. X equals to minus 5 and minus 4 over 3. And we are given horizontal asymptote as y equals to 0. We also know this condition. When is the function positive? When is negative? So what we will do here is first sketch the quadratic function. Let's say we'll sketch g of x, which is quadratic function. So what we know here is that the function has 2 asymptotes. One is at minus 5, let's say this is minus 5. The other one is 4 over 3, which is slightly greater than 1. So let's say that is 4 over 3. And if you sketch the quadratic function, it will have these x-intercept for sure, but it could be opening upwards or downwards. How do we decide that? Now that is decided from this given condition. When x is less than minus 5 on this side or on that side, so in these two sides, y is less than 0. So we are given y less than 0. That means negative. Is it okay? So reciprocal of negative is negative, and therefore the parabola should be kind of like this. Do you see that? So that becomes the parabola for which we have to write the equation, right? So opening downwards means what? Means negative, right? Leading coefficient negative. Perfect. And therefore, now we can write the function, let's say f of x is what? Since it opens negative, we'll write negative 1 on the top, right? And since it has these intercepts at minus 5, it gives me one factor, which is x plus 5. And also, it has another asymptote at 4 over 3. So 4 over 3 means the factor should be, we have x minus 4 over 3 you could write. You could do that, right? So, but you could also write like this. Well, let's write 4 over 3 first. So that could work. But it is always preferred to write this answer as, let me rewrite here, f of x equals to negative 1 over. So we can write this as 3x minus 4. Do you get an idea? So we have x plus 5 giving you this particular vertical asymptote at x equals to minus 5. And then we could write this as 3x minus 4. Right. So this equation here is x equals to 4 over 3. Perfect. And since the denominator degree is higher, we know that the horizontal asymptote should be the x-axis. Is it okay? So that becomes the horizontal asymptote, right? So if you sketch the graph, it will look like what? It will look like this, right? It will look like this. This is negative portion, so it is going to look like this, which is not a part of this question, but can definitely be part of your question in the test paper. Perfect. So what we get here is the function, which is a reciprocal quadratic function, which meets all these conditions. Is that clear? So that should be, so it could be any value here, right? So we just wrote -1, simplest answer. Let's go to question number 2 now. It says determine equation of tangent line to the graph of this function. Now, different methods could be adopted, right? You could actually use calculator, take a point, find slope, using 2.001 as another point, correct? And then find the equation of the tangent line. Is that clear? So one method is that you can find the value of the function at x plus h, right? You know already x value. So there are two methods to this. Since we know x is equals to 2, right? So we could find the value at 2.001, correct? So that could give us one value. And then we know at 2 it is, we know at f of 2 it is 6. And therefore the slope m will be equal to f of 2.001 minus f of 2 divided by 2.001 minus 2, correct? So that gives you rate of change. Since it is equation of a tangent line, so the points are very close. Do you see that? So let's do this. So we'll substitute 2.001 here. So we get 3 times 2.001 plus 6 equals 2 divided by 2.001 equals 2. We get this as equals to 5.9985, right? So what we are doing here, we are trying to find slope. So slope m is equals to f of 2.001 minus f of 2 divided by 2.001 minus 2, correct? So what we get here is, when I substitute this value here, we get 5.9998, right? That is the value of, so we have here 5.9985 minus, at 2, we are already given value of 6 divided by 2 minus this is 0.001. Is that clear? So from this value, we'll take away 6 and then we'll divide by 0.001. So that gives you a slope of minus 1.499, correct? So which I could round to minus 1.5. Does it make sense to you? Correct? So that becomes the slope m at 2. Now the question is to find equation of tangent lines. So we can use the equation of the which you could also write this in fractions. Sometimes it's better, right? So let's write this in fraction, which is 3 over 2. Is that okay? 1.5. Now we can use the equation of tangent line, which is y minus y1 equals to m times x minus x1. Correct? x1, y1 is given to us as 2, 6. So that's the point which we are interested in. So the equation of tangent line will be y minus y1 is 6 equals to m of minus 3 over 2 times x minus 2. Now you cross multiply, so you get 2 times y minus 6 equals to minus 3 times x minus 2. Open the brackets, you get 2y minus 12 equals to minus 3x plus 6. Bring them together, one side, keeping coefficient of x positive. So we get 3x plus 2y minus 12 minus 6 equals to 0. That gives you 3x plus 2y minus 18 equals to 0. So that becomes the equation of tangent line. Is that clear? So that is how we can get equation of tangent line at a given point for a rational function. Perfect. So let's move on and take the next example. Question number 3. Solve x squared plus 1 over x squared plus 2x plus 2 over x equals to 13. Now this is a bonus question, sometimes seen in the test paper. It's not an easy question. So let me rewrite the equation. It is x squared plus 1 over x squared plus 2x plus 2 over x equals to 13. Okay. Now to solve this is kind of like this. You could write some variable y equals to x plus 1 over x. Why did I choose that? You see it is kind of x plus 1 over x, right? Let me rewrite and show it to you. It is kind of x squared plus 1 over x squared plus, I can take 2 common, and what I get here is x plus 1 over x, and let me bring this 13 this time to the left equals to 0. So you get this kind of x plus 1 over x. So it gives you an idea that that substitution can simplify. That's the whole thing. So now, how do we write what is x squared plus 1 over x squared? So let us square both sides. Let's square both sides. So if I square, I get y squared equals to a squared plus 2ab. So twice, when you multiply x times 1 over x, you get just 2 plus 1 over x squared. Do you see that? So y squared is actually equals to x squared plus, this is just number 2, right? So let me write 1 over x squared first, and then I'll write plus 2. Does it make sense? So we wrote this here. Okay. So from here, we can always say that x squared plus 1 over x squared is y squared minus 2, right? So we get y squared minus 2 equals to x squared plus 1 over x squared. Does it make sense? Perfect. So we are going to use this substitution. So instead of x squared plus 1 over x squared, I can write y squared minus 2. So here I'm writing y squared minus 2 plus 2 times, this is y for me, right? Minus 13 equals to 0. Does it make sense? So what I've done here is use this substitution x squared plus y and replace it with this portion. Is that okay? And on the other side, I've used this portion and substituted for this portion. Perfect. So that is how you get these terms. Correct? Now it's a quadratic equation, right? So we could solve it. We have y squared plus 2y minus 15 equals to 0. 5 times 3. So we could do y minus plus 5, let's write first, and y minus 3 equals to 0. That gives you two values for y, which is minus 5 or y equals to plus 3. Correct? So that is what y is. So we get two values of y. Either it is minus 5 or plus 3. Now for these two values, what we should do is we can find what x value is. Correct? So y is actually x plus 1 over x. So now the question is, if I write y equals to minus 5, what is x? So I'm writing minus 5 is equals to x plus 1 over x. Is it okay? And then we have to find what x is, correct? So if I multiply by x, I get minus 5x equals to x squared plus 1, or rearrange, we get x squared plus 5x plus 1, correct? Equals to 0. Now to find x, we have to use quadratic formula, correct? So we get x equals to minus 5 plus minus b squared, which is 5 square of 25, minus 4ac, which is 4, divided by 2a, which is 2. So these are the two values, correct? So that is what you get. You can always calculate this answer, right? So I'm not extending it. We'll just keep it kind of like this. 21 over this we'll write. Okay. The next one here is 3. So we can write this 3 also as x plus 1 over x, multiply, we get 3x equals to x squared plus 1. Bringing them together, we get x squared minus 3x plus 1 equals to 0. So x is equals to minus b means 3 plus minus 3 squared is 9 minus 4 over 2. You see that? So that becomes your solution. So we get two solutions for x in this particular case. Is that right? So let's rewrite these answers. Now we know here that the restriction is that x is not equal to 0. That is the restriction for us. And now these are the solutions. So we can write here that this is minus, plus minus. So let's write down our answer as x equals to minus 5 plus minus square root of 21 over 2. And also this will give you 3 plus minus square root of 5 over 2. Right. Now I'm leaving it here. What you should do, actually speaking, is check each solution. Okay, and once you check, then you write the answer, right? Not like this. Just don't write just because I'm saying it. It's okay. So substitute this value in the equation and see whether you get 13 or not, right? So check each solution and report answer. Is it okay? So I'll wait for your answers, right? So for me, tentatively, so probably I'm writing. Is it okay? So probably x is equal to this or this. You may make your choices. Maybe I'm correct, okay? But you need to test it out. So I hope that makes sense, right? So that is another very important question. The last question here is question number 4, which is find a, b, and c, where we are given a over x plus 1 plus b over x minus 2 plus c over x minus 2 whole square equals to x minus 1 divided by x plus 1, it should be times x minus 2 whole square, right? So that is the equation. How can you do this? Okay. I'd like you to pause the video, answer the question, and then look into my suggestions. This is another very interesting question. So what we will do here is we'll begin with the left side. So let's take the common denominator. So from the left side, we have the common denominator of x plus 1 times x minus 2 whole square, correct? Okay. So if that is the denominator, a should be multiplied by x minus 2 whole square plus b times, that has to be multiplied by these two factors. So we have x plus 1 times x minus 2, and c should be multiplied by x plus 1. Does make sense to you, right? Now we have to expand all this. So what we get here is a times x squared minus 2ab means 4x plus b squared means 4, plus we have bx plus b, let me expand this first. So we get x squared. When you multiply this, we get x squared, and we get minus 2x and plus x. So okay, so when you multiply this, you get minus x, and when you multiply plus and minus, you get minus 2, plus c times, we get x plus 1 to be divided by x plus 1 times x minus 2 whole square, right? So that is what you get. Now let us expand the numerator. So what we have here is, or bring down the x squared terms together. Is it okay? So, okay, let's do it in 2 steps. So we get ax squared. Okay, so let's write like this: ax squared minus 4ax plus 4a. As far as b is concerned, we get plus bx squared minus bx minus 2b, and c we get plus cx plus c over x plus 1 times x minus 2 whole square. Now we will combine the coefficients for x squared, x, and constants. So what we get here is, for x squared, the coefficients are a plus b. Okay, how about x? For x, it is minus 4a and minus b plus c. And the constants, we have 4a, as far as b is concerned, minus 2b plus c, right? So these are the constants for us. And the denominator is x plus 1 times x minus 2 whole square. Now from these, what do we get? The numerator here is x minus 1. Do you see this numerator, right? So this means there is no x square term, correct? So that means a plus b should be 0, right? So we get a condition which says that a plus b should be 0, right? So from here we get a plus b equals to 0, right? Now here, if you compare the coefficients, all this should be 1. So what we get here is minus 4a minus b plus c equals to 1. And minus 1 should be equal to 4a minus 2b plus c equals to minus 1. Does make sense to you? That is what we get. Now, it is a question of solving equations simultaneously. Correct? So what we can do here is, let's call this equation as 1, 2, and 3. Since I've run out of space, I've kind of used both these areas. So first step, what I will do here is get rid of c, right? So we could do equation 2. 2 minus 3, okay, I did. That's fine. So 2 minus 3, if I do, minus 4a gives me minus 8a. And b, if I take away, I get plus b. And 1 minus 1 actually gives me 2. Correct? So we get 8a plus b as 2. We already have a plus b as 0. So this is, let me call this as equation 4. Since we have a plus b equals to 0, what we can do here is we can do equation 1 minus 4, right? So if I do equation 1 minus 4, it is basically a question of solving simultaneous equations now, right? So if I do 1 minus 4, I get 9a, right? A minus 8a. B minus b is 0, and 9a equals to, we are doing this minus that, equals to minus 2, and that gives you a as equals to minus 2 over 9. Correct? So we get value of a. Now from here, we know b is minus a. We know b is minus a, so b should be 2 over 9. Perfect, since a is this. So we got one solution b a as 2 over 9, and we have another solution b is plus 2 over 9. Now to find c, we can use one of the equations. So let's use any one of them. So we'll use this one. So we got c equals to, rearrange 1, bringing these terms to the right side, 4a plus b. That is what it is. So which is 1 plus 4 times minus 2 over 9, minus 2 over 9, and b is 2 over 9. Correct? So that is, let's take 9 as common denominator. So we get 9 minus 8 plus 2. So 9 plus 2 is 11, minus 8 is 3. So we get 3 over 9 or 1 over 3. Is it okay? So C is 1 over 3 for us. So that gives us the solution. Let me push the page a bit and write down the answer. So what we get here as our answer as A equals to minus 2 over 9, B equals to 2 over 9, and C equals to 1 over 3. So that is how it could be solved. So I hope you enjoyed this journey of review of rational functions. In part 1, we discussed the basics. We took up very good examples, knowledge-based and communication-based. And in part 2, we have taken us some typical thinking questions, which could be expected in your final exam. Feel free to write your comment, share your views, and once the exam is over, please post your questions also. If you like and subscribe to my videos, that would be great. Thanks for watching and all the best.